So convert 2 over pi radians to degrees in minutes and seconds. So if this is in radians, we want the radians to cancel, so we'll put pi radians in the denominator, which is 180 degrees in the numerator, and we'll multiply this, so we're going to get 360 divided by pi squared, which is 36.47562 degrees. Now change it to degrees, minutes, seconds. We subtract the 36 because we know it's 36 degrees and multiply it by 60, and we get 28 minutes. And subtract the 28 and take it times 60, and we get the seconds to be 32 seconds. Number 2, convert this to radians in decimal form. So we have 232 plus 35 sixtieths plus 14 3600ths, or 60 squared. So it's that many degrees. And so to convert it to radians, we got to get the degrees to cancel. So we put 180 in the denominator and pi in the numerator. So we take it times pi divided by 180, and we get 4.05941 radians. The exact value of this, well, see the cosine of negative 135, negative 4590, 135. The cosine is minus square root of 2 over 2, and that's multiplied by the square root of 2. Cosecant, which is 1 over the sine of 5 pi over 6. So 1, 2, 3, 4, 5, 6, that's 150 degrees, or 5 pi over 6. The sine is 1/2, and so 1 over it would be 2, so this is 2. Square root of 2 times square root of 2 is 2, divided by 2 is 1, so we got minus 1 minus 8, which is negative 9. 4. Secant is 5/3, so the secant is reciprocal of the cosine, so the cosine is negative 3/5. And if the tangent is positive, determine the tangent of 2 theta. So we need to know the sine of phi. So if the cosine is negative and the tangent's positive, we have to be in this quadrant. And if the cosine is negative 3/5, the sine would have to be negative 4/5. If we do sine squared plus cosine squared equals 1, we'd get the square root of 16/25, and we have to use the negative 1, negative 4/5. Tangent of 2 theta formula is 2 tangent phi over 1 minus tangent squared of phi. So we'd have 2 times the tangent would be sine over cosine, which is negative 4 and negative 3, which is 4/3, over 1 minus 4/3 squared. So that's 8/3 divided by 16/9 from 1 is negative 7/9. So that turns out to be negative 72 over 21. Which reduces, I believe 3 goes into both of those. That would be negative 3 and 72 is 14? No, 24 over 7. Yeah. Okay. Graph this. So the amplitude is 2. The period is 2 pi normal period divided by the coefficient here, pi over 2, which turns out to be 4. So if I do 1, 2, 3, 4, that's going to be 4. 1, 2, 3, negative 4, and negative 2, so minus 1, minus 2, 1, 2. Cosine would normally start at the top, but since it's minus 2, it would start at the bottom, and the first quarter be on the center line, then it'd be at the top, then be on the center line, and then at the bottom, down 2. It's down 1. I missed that minus 1 there, so we got to move all this down 1. So center line would be here, and so it'd be at the 2 below it, and then on the center line, then 2 above it, the center line, then on the center line, and then 2 below it. That's where it looks like it's going to go. Back on the center line, 2 above the center line, back on the center line, 2 below the center line. But it's also moved 0.5 to the right, and if that's 4, that's 3, 2, 1, and 0.5 would be that much. So now it really goes right here. 2 above gets moved over to there, on the center line gets moved to there, and 2 below goes there. Nope, there on the center line. And the 2 above. And then back on the center line there. And the bottom there. Okay. Describe the transformations. Okay, it's the minus 2 is a vertical flip and vertical stretch by a factor of 2. The pi over 2, which is bigger than 1, makes it a compression. You notice the period is 4 instead of 2 pi, which is 6, so it's a horizontal get it up here, horizontal compression by a factor of pi over 2, and it's down 1 and right 0.5. Determine the equation for this. All right, so if this is 2, this is 1, and this looks like, what, 1.5 is the low, and the max is at, it looks like 2.5. So the amplitude is 1/2. It's starting on the bottom, cosine starts at the top, sine starts in the middle on the center line. The center line's at 2. So this looks like a negative cosine of an amplitude, and then the period goes from a top at, let's see, if that's -2 and that's -4, that doesn't look like it's right on 3. It looks like it's a little bit past 3. So I'd say that's minus pi to plus pi. So that's 2 pi to go from top to top. So it's a normal period, so it's just going to be cosine x raised up to 2. Normal period, no sideways shift, so that was it. Now this one, the max is 5, the min is, it looks like 1. So the center line would be at 3, so we got up 3, amplitude of 2, and let's see, if I make the curve in here, the asymptotes are about here. So it's going to cross the center line there. It's going to touch there, cross at the asymptote, up there, cross at the asymptote, which is going to be about there, and down there. So this looks like it's close to being at the top, so I'll call that a cosine for this curve. So this curve would be the reciprocal of cosine secant. And looks like the period goes from there, which is 4.5, and over here is 3 minus 3.5 to 4.5. That's a period of 8. So 2 pi divided by 8 is pi over 4 x, and it looks like it's shoved over 1/2 in the plus direction, so I got minus 0.5, and I think I got it moved over 0.5, got it flipped over, so I think that's it. Let's check that. So mode, get it out of polar, y equals, clear, put in 2 divided by cosine, pi divided by 4, parenthesis, x minus 0.5, close parenthesis, plus 3, and then mode we have to be in radians, so that's what we're doing this in, and zoom trig, which is 7. Okay, there's the ones that are down, and I don't see the ones up because I'm not looking high enough. So I gotta make y max be like 8. And one on top, one on bottom, on top, one on bottom. That's looking pretty close. Okay. Sinusoidal curve. So I can put this data 1, 2, 3, 4, 5, 6, 7 into list 1 and put this into list 2 and let the calculator do the sine regression. Or I can say the min is 5.28 The max is 19.21. So if I add these and divide by 2, I get the vertical shift. 19.21 plus 5.28 divided by 2. I get the center line is up 12.25-ish. And then we can get the period. See, this is 12-month period, so 2 pi divided by 12 is pi over 6. And x, or t, time, and let's see, this is hours of daylight in Anchorage. So on December 21st is the lowest, and this is the 21st of each month. So if December is 0, that's the time we want that to be. So we don't need to shift it sideways. No, see, we want the cosine starts at the top. Well, we're supposed to do the sine. So the sine starts on the center line and goes up and down and up. And we want the lowest to be at 0. So we'd have to move the sine over 1/4 of a period. So the period is 12 months, so we'd have to move it over 3 months to be the low part at 0. December is 0. So -3 to move it plus 3 months. That would get the months right place. And we want to do the sine it said to do, and the amplitude is going to be halfway between these, or half of the difference. So I got to do those same numbers, but subtract, and then divide by 2, and I get 6.96, about 7. And that would be the daylight hours. Equal that. Or y if you want. That should be close to what we get if we do the calculator. Oh, plus the 12.25. Okay, next page. Determine the exact value of this. So square root of 3 over 2 is a special angle. Square root of 3 over 2 for cosine is over here either at that one or that one, but we're supposed to do capital, which is in the first and second quadrant. So that would be pi over 6. Or get it in radians, so that's correct. Cotangent is -1, which means the tangent inverse is -1 also. And the tangent is -1 here and there. But we do inverse cotangent out of these two quadrants, so we're going to do 3 pi over 4. And then cosine inverse again of the cosine, 11/8. And that's positive, so that's 8. And 3 more 8s would take us somewhere in here. So the cosine's this negative value. But we have to take it out of the first or second quadrant, so we would want to use an angle that's up here. And that would be, this was 1/8 short of being here, so it'd be 1/8 past here, so it's 5/8. 5 pi over 8. Okay, the tangent has a value of, see, tangent is, let's do a triangle, opposite 1 over adjacent u. So the hypotenuse would be the square root of u squared plus 1 squared. Now we're supposed to find the sine of this angle. The sine is opposite over hypotenuse. And there's the answer to that one. Then, let's see, 9. Simplify this. Well, if this is minus and it's cosine, sine, sine, cosine, that's the sine difference formula. So that's the sine of 2 pi over 3 minus pi over 6. So that's 4 6 minus the 6. It's sine of 4 6 minus 6 is 3 6. 3 pi over 6, which is pi over 2, which is 1. And then we're supposed to do this one. So the tangent of two angles subtracted is tangent of pi over 3 minus tangent of the second angle over 1 plus tangent of the first one, tangent of the second one. So this becomes tangent of pi over 3. Pi over 3 is the sine is square root of 3 over 2 over a half, so it's just square root of 3. So this is square root of 3 minus tangent x over 1 plus the square root of 3 tangent x. Okay, now that doesn't look necessarily simplified, but it's an alternative version of it. We've got the tangent of the pi over 3 taken out of it, so we only have tangent x left in it. That's why it's considered simplified. Prove this is equal to that. Sine of alpha minus beta is sine of alpha cosine beta minus the same sign for sines, cosine alpha sine beta. Secant is 1 over cosine alpha. Cosecant is 1 over sine beta, so those go in the denominator. If I put this under these, I get sine alpha over cosine alpha, which is tangent alpha. And I get cosine beta over sine beta, which is cotangent beta. And if I put it under this, I get 1. Prove this is true. So cosine of 2 thetas, cosine squared theta minus sine squared theta plus sine squared theta over cosine theta. So these cancel, and I get cosine squared over cosine of theta, which is cosine theta. Find all the exact solutions to this. So we take the sine inverse, and we got the sine inverse of minus square root of 2 over 2. But we're not doing capital, so we got to do all the possibilities. See, the sine is minus square root of 2 over 2, right? Minus square root of 2 over 2 there and there. So this would be pi over 4 minus pi over 4 plus multiples of 2 pi. Or x could also equal over here, which is, I could go minus 3 pi over 4 or plus 5 pi over 4 plus multiples of 2 pi, where m is an element of the integers. Okay, this one. Oh, I get let you do it in degrees this time. So tangent squared of x equals minus 3. So if I subtract 3 and take the square root, I get the tangent of x equals plus or minus the square root of 3. That happens to be special angles. Tangent's the square root of 3 at 60, 120, 240, and 300. So we could say it's plus or minus 60. That would get these two. And these are right 180 across from them, plus multiples of 180 would get those and all the multiples thereof. So x could equal this. Okay, this looks very familiar. It's a little bit different here. Determine the values of x and y. And we got side, angle, side. So there's only one solution to this one. And side, angle, side is law of cosine. So we'll do x squared is equal to 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of the angle between. And so I got to take the square root of that. Square root of 25 plus 9 minus 2 times 5 is 10, 30. Cosine 67, close parenthesis. You know what I need to do here? I think my mode's still in radians from earlier, so I need to change the degrees. And I get x to be 4.72. And to get y, I can use the law of sines. Now that I have this, I want an angle, so the sine of y over the side opposite equals sine of another angle, 67, over the side opposite, 4.72. So I'm going to multiply by 5 and take the sine inverse. So I've got the sine inverse of 5 times sine 67 divided by 4.72 close parenthesis. And everything, yeah, I think so. We get 77.2. And let's just check it. Program sine angle sine is cos law. Degrees, side angle side. Angle was 67. Adjacent side 5. The other adjacent side 3. And we've got 4.72. And with the 3 sides, I can use law of cosines again. 1 and do side, side, side. And I want the opposite the angle I want, so that would be 5. Adjacent side 3. The other adjacent side is 4.72, and it says the angle is 77.2. All right. Determine x. We got 3 sides. That's law of cosines. That's adjacent side squared plus the other adjacent side squared minus the opposite side squared over 2 times the 2 adjacent sides, and cosine inverse. It's supposed to give us x. And so we have cosine inverse of numerator 14 squared plus 27 squared minus 15 squared, that's the numerator, divided by denominator is 2 times 14 times 27. That's the denominator. That's what we got to take the cosine inverse of, and that is 22.2 degrees. Check it with the cosine law, which was degrees and side, side, side. And the opposite side is 15, 14, 27, 22.19. Next page. Find the length to segment AB. Well, we have two angles and a side on a triangle. And we have a 10 over here, which doesn't really help us at all. But if we have two angles, we know the third angle, and we should be able to use the law of sines and not have to do anything with this. So, law of sines, and we want AB up here. So, law of sines says x over the angle opposite equals another side over the angle, sine of the angle opposite. So we just have to do 9 times the sine of 105 divided by sine of 15, and we get x to be 33.59. 17. Radar spots a plane east of its position at a distance of 7. So there's a plane. Here's the radar, 7 miles to the east. There's a plane. And a second plane at 5 miles at an angle of 22 degrees south of east. At a distance of 5 miles. And how far are they apart? Side angle side. So to get that, we do x squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine 22. Or we could add them up as vectors, but that looks like that would be the easiest. So we're going to do the square root of 25 plus 49, 10 times 70 minus 70 cosine of 22. And we get x equals 3.016 miles. Now, if you wanted to do it in the table, we would have 7 at 0 degrees. So that's going to be 7 in the x and 0 in the y. And we'd have 5 at negative 22. So that would be 5 cosine negative 22, 4.635, and 5 sine of negative 22, which is 1.873 negative. Add these up, we get 11.635. And, oh, I'm not trying to find not trying to add these vectors, and that's what I was doing. So no, I don't want to do that. Just want to find the distance between them, which would be if I took this vector and subtracted that one. I would have to subtract these. I knew I was getting something wrong here. I could do this by doing this and subtracting. I'd get 32.365, and 0 minus that is 1.873. And if I square and add those two, I get the length of that. It's going to be 2.365 squared plus 1.873 squared, and then take the square root, and I get the answer I had before. Okay. Convert rectangular coordinates to polar. 49 plus 25 is 6074 for the radius, and the angle would be tangent inverse of 5 divided by 7. Don't have to add 180 because x is positive, so at 35.53 degrees. To make this rectangular, y is r. This is rectangular, so we make it polar, so it's r sine theta plus 2. And x is r cosine theta, but we got it squared, so it's r squared cosine squared theta equals 4. This is in polar because that's their degrees, and so we're going to do, to convert that, we're going to do minus 2 cosine of negative 220. So that's 1.53, and the y is going to be sine, which is negative 1.29. Secant is 1 over cosine theta. So if I multiply both sides by cosine theta, I get 3r cosine theta equals 1. So r cos theta is x, so I get 3x equals 1. Now I have a ship sailing at a 22 degrees east of north. There's north, east is on this side, so it's 22 degrees on the east side of north, going at 4 knots. It's causing a drift. The current is 2 knots towards the southwest. So there's a current this way of 2. So that's going to really hinder that boat a lot. Now we can make this a triangle, or we can do it, I'll do the table form on this one just to make it easy. So if I'm doing trig, there's 0. So if it's 22 off of there, it's 68. So we got 4 at a trig angle of 68. And then we have the 2 going in that direction. So that's 2 at an angle of 225. So the x is 4 cosine 68, 1.498. The y is 4 3.709 to this is going to be minus, okay, 2 cosine 225 is minus 1.414, and 225 is special. It's going to be the same. They're both negative in that quadrant, minus 1.414. Add these, so they're going to actually subtract, and so that's going to be 0.074, and this is going to be 5. 1 from 0 is 9, 4 from 6 is 2, and 1 from 3 is 2. X is positive still, so we don't have to change that. So we're going to do tangent inverse of 2.295 divided by 0.074. So to get to there, it's going to be at an angle of 88, and that's going to be almost 90. It's 2 degrees, basically 2 degrees east of the north direction. So north 2 degrees to the east, and the speed is going to be 0.074 squared plus 2.295 squared, square root, and that's going to be 2.296 knots, roughly 2.3 knots. Last page. How do we get something to look like that? 1, 2, 3, 4, 5. So it's out as much as 5, and then in this looks like a negative radius of -1. So that's a difference of 6. So it must be based on a circle of 2, 3 more, and 3 less than 2. So I'm going to base this on a circle of size 2. So it's going to be, the R is going to equal 2. And it looks like we add 3. And to be adding right at 0 degrees, that would be a cosine curve. And it looks like it adds and then goes to minus, and cosine's minus over here, and then plus, and so I think it's just theta. Let's check it. So mode, polar, 2 plus 3 cosine theta. That looks pretty darn close. Given this vector, then determine the vector in polar form. So the radius would be 5 squared, 25 plus 144 square root. So that's 169. Square root of 169 is 13. And then the angle would be tangent inverse of -12 divided by 5. And the x is positive, so we don't have to add anything, at -67 degrees. Determine the unit vector. Okay, so this has a length of 13, so it would be 5/13 I minus 12/13 j. Last problem. U plus V. So I'm going to do U, should look about the same direction, same size, plus V, and V goes this way. So there is U plus V. And 4 V's, ooh, that's going to take me a long way over there. So I'm going to start way over here and go 1, 2, 3, 4 V's minus U. That's going to take me up about there. So this would be this, 4V minus U.